Okay. Y2. We can find the slope by the difference of y coordinates divided by the difference of the x coordinates. Okay. පළවෙනි පාර්ට් එකෙන් කතා කරේ ස්ට්‍රේට් ලයින් එකක ස්ලෝප් එක ගැන අනුක්‍රමණය ගැන. ඒක හොයන හැටි ඔයගොල්ලෝ දන්නවා මේ රේඛාවෙන් නේ. එතකොට මේකෙන් එතකොට වෙනස් වීමේ x යුනිට් එකකින් වෙනස් වෙද්දි y වෙනස් වෙන ශීඝ්‍රතාවය තමයි දෙන්නේ. Okay, it gives the rate of change of y when x changes by 1 unit. So we call it the rate of change. How much y change when x change by 1 unit, that is called the rate of change of this y, no, with respect to x. Okay. So now we want to find the similar thing for non-linear curves. That means not straight lines. Okay. So they have some curve. Okay. අපි දැන් හදන්නේ මේ වක්‍ර වෙච්ච සරල රේඛාවලටත් මේ අනුක්‍රමණය වගේ ලක්ෂයකදී වෙනස් වීමේ ශීඝ්‍රතාවය හොයන්න. Okay. So the problem is if we draw a line tangent like this, we can know the tangent line's coordinate, but we cannot find another point on this line to find the slope. Okay. So we need 2 points, no? Okay. So therefore we do a 3. Okay. But if we draw like this line, these are called secant lines. We can find it connect 2 points on the curve. We can find the slope of a secant line easily. But secant line don't give what we want. Okay. It gives average speed in here, average rate of change, not the rate of change at the point. මේ දැන් අපිට මේ ස්පර්ශක රේඛාවේ අනුක්‍රමණය හොයන්න ඕන. ඒ ස්පර්ශක රේඛාවේ අනුක්‍රමණය තමයි මේ පොයින්ට් එකේදී rate of change එක දෙන්නේ. අපිට ඒක හොයාගන්න බෑ. ඒක උඩ අපි දන්නේ එක ලක්ෂයයි. හරි? හැබැයි අපි මෙහෙම secant line එකක් draw කරොත් ඒ පොයින්ට් එක හරහා යන ඒ කියන්නේ ඒ secant line එක point දෙකක් connect කරන line එකක්. Okay, but it don't give the rate of change at the point. It gives the average rate of change between the 2 points. ඒකෙන් දෙන්නේ ඒක ඒ රේඛාවේ අනුක්‍රමණයෙන් අපිට ඕනේ rate of change එක හම්බ වෙන්නේ නැහැ මේ point එකේදී. ඒකෙන් දෙන්නේ මෙන්න මේ ලක්ෂ දෙක අතර වෙන සාමාන්‍ය rate of change එක. average එක rate of change එකේ. Okay. So we use a trick. So what we do, let's say I have this graph. Okay. We have this graph.
Good morning, buddy. Vacation course, the motion done, the hatad. The palo.
Okay, someone's mic is. So we want the tangent, the slope of this tangent line. Okay. We call it x. Then the y coordinate given by fx naught, no? Because this is the graph of fx. So y coordinate we can find by plugging in the x coordinate x naught into this guy. Okay, if we plugging in x naught into this guy, I can find the y coordinate. Now we need slope of this line, but what we do, we don't go h unit. So here actually here x coordinate is x naught, no? Okay, we go h units away from here. So this is from here to here h. Okay, and here to here x naught, no? So the y x coordinate on this point is x naught plus h. Okay, මේකෙදි දැන් මට මේ ස්පර්ශක රේඛාවේ අනුක්‍රමණය හොයන්න ඕන. ඒක හොයන්න තව ලක්ෂයක් ගන්න නැහැ මේක උඩ. එතකොට මට ඒක හොයාගන්න බෑ. එතකොට මම කරන්නේ මේ x0 ඉඳලා මෙහෙට යනවා h0 h දුරා. එතකොට මෙතන ඉඳලා මෙතෙන්ට x0 නම් මෙතන x කණ්ඩාංකේ x0 දාන x+. හරි? එතකොට මෙතෙන්ට ගියාම here x coordinate is x0 plus h. So here x coordinate is x plus h. x0 plus h. Y coordinate is fx0. Okay. Now what I do, this is the point on the graph here, no? I draw the secant line here, connecting these points. Okay. Now I can find the slope of the secant line. මට secant line එකේ මේ ලක්ෂ දෙක draw connect කරන රේඛාව හෙව්වොත් එයාගේ slope එක හොයන්න පුළුවන් මේ රතු රේඛාවේ MH එක. ඒකට මම මේ ලක්ෂ දෙක තෝරගන්නවා. I choose this was as x2 y2 and this one as my x1 y1. Okay, so then mh is equal to y2 minus y1 difference of y coordinate divided by difference of x coordinate. This is the formula for slope of this straight line, no? Slope of this line mh. Okay, මේ අනුක්‍රමණය මේ රතු රේඛාවේ දෙන්නේ මේකෙන් නේ y කණ්ඩාංක වල වෙනස රිනවා x කණ්ඩාංක වල වෙනස. එතකොට y කණ්ඩාංක කියන්නේ x0 plus h, that is the y coordinate here. Okay, here when I plugging in, actually I did a mistake. No, this is what x0 plus h, sorry. Okay, because this x coordinate here is x0 plus h, I plug into the graph, I get x0 plus h there. Okay, minus fx0. මෙතන මම mistake එකක් කරා, මේ x0 දැම්මම y coordinate එක f0 plus h නේ. Okay, then denominator x0 plus h minus x0. Okay, so this one I can cancel out this x0, so I get what, f x0 plus h minus f x0. මෙතන x0 එක cancel කරාම denominator එකේ ඉන්නේ h නේ. okay, මේකේ denominator එකේ ඉන්නේ h. now I have to find the, now what happens, this is the slope of this red line, but if I send this h to 0, okay, if I send this h to 0, this point going to go like this, and this red line going to overlap with the blue line like you saw in the video. මේක මේ h එක බිඳුවට යවනකොට මම මේ රේඛාව රතු රේඛාව එන්න මේ බ්ලූ එකට ලං වෙලා ඒක උඩටම එනවා නේ හරියටම. කියන්නේ h බිඳුවට යද්දි මේ රතු රේඛාව මෙහෙම ගිහිල්ලා බ්ලූ රේඛාවට යනවා. මේ පෙන්නලා තියෙන්නේ මෙතන h පොඩි කරන්න මෙතන ඉඳලා මේ ලක්ෂ මෙහාට යනවා. එතකොට මේ තියෙන මෙතන එන්න මෙන්න මේ රේඛාව L එකට ලං වෙනවා tangent line. Okay, so this red line get close to the blue line. Okay, so at the exactly h limit, so if I send h limit to 0, this one keep getting closer to this one, so we expect the limit of this limit of x going to 0 to be of mh to be the slope of the tangent line, because red line collapse or overlap to the tangent line at the limit. We call this limit is this one. Okay, so that means actually the derivative of the tangent line, we can, sorry, the limit of the slope of the tangent line is the limit of this slope of the red line when h goes to 0. Okay, so limit of these red lines like this when h going to 0 gives the slope of the tangent line. එතකොට මෙන්න මේ h කියන එක බිඳුවට යවද්දි මේ රතු රේඛාව මේ tangent රේඛාව මතට ලං වෙන හින්දා ඒකට පතිත වෙන්න යන හින්දා මේ tangent එකේ අනුක්‍රමණය ගන්න පුළුවන් මේකේ සීමාවෙන්, මේ slope වල මේ අනුක්‍රමණ වල සීමාවෙන්, මේ secant line වල වල සීමාවෙන් දෙනවා tangent line එකේ slope එක. Okay, so we call this is the derivative. Okay, so we call this limit the derivative of function at x naught. Okay, so this is the definition of the derivative. Do you guys have any questions, or do you want me to explain it again? කාට හරි ප්‍රශ්නයක් තියෙනවද? ඒක විස්තර කරන්න ඕනේ කවුරු හරි ඉන්නවද? chat එකේ හරි අහන්න පුළුවන්. හරි, එතකොට මේ derivative among, I will show you how to use this definition and find the derivative for one example. Then we will go for a little bit easier method. So we'll go and say we want to find the derivative of this curve fx equals x squared. Okay, so if x squared, we want to find the derivative of this guy at x naught. Okay, x equals x naught. So the formula for derivative, I will call the derivative of tangent line equals limit h goes to 0 f x plus h x naught, no, at x naught, so plus x or naught divided by h. Okay. Now if I here x naught plus h, here I'm plugging into the function, no? මෙතන මේ සමීකරණයෙන් තමයි ඩෙරිවේටිව් එක දෙන්නේ. එතකොට මේක f ට ප්ලග් කරනවා මම x naught, no? f is x squared, so x naught plus h squared minus x naught squared over h. Now it this limit, if I directly plugging in, I get 0 over 0. Okay, so because of that I try to get that thing cancelled like you saw in the last problem. Okay. So here I can FOIL this, no? X naught plus h, I can write it like naught plus h times x naught plus h, this square, no? For example, we have a 2 square, 2 times 2, 4, no? So it's the same thing. H. Okay. මෙතන මේකට ප්ලග් කරා සබ්ස්ටිටියුට් කරා ඊළඟට මේක විහිදවලා ලියනවා. You will see why I am doing that in a minute. Okay, so I do this x naught squared plus hx. Okay, x naught squared plus hx naught. Here again hx naught, if I add them I get 2x x naught. Okay, you will see that when plus h squared, when expand this one මේක විහිද වැඩි කරාම මෙහෙම මේ term එක එනවා. Okay, so here we have x naught squared everything divided by h. Here this x naught squared get cancelled out. Okay, I get h in the denominator here. Okay, now I can pull out this h as a common factor, no? Yeah, I'll do it here. Pull out. So h, and I can cancel out the h in the denominator. Okay, so I get 2x naught plus h. When h goes to 0 I get 2x naught. Now limit x going to 0, this will goes to 0, so limit here is 2x naught. Okay, now derivative of fx, derivative of fx at x naught is, that is the slope of the tangent line, is 2x naught squared. Okay, so this derivative is a function of x naught also, no? So example, derivative at 2 will be what? X equals x equals 2, that means x naught is 2, no? So that will be 2 to the 2 square, 4 times 2, 8. And if I want the derivative at 3, that will be x naught is 3 now, no? So 3 squared, 9, 18. Okay, in general derivative at x, I can say it's 2x squared, no? In at a general point x, derivative is 2x, sorry, 2x. Okay, sorry, it's just 2x, not squared. Okay, let me correct that, sorry. Here, 2x naught, no? So here, derivative x here is 2x naught. So derivative at, let's say if you want at 2, I will tell this one 2 times 2 equals to 4, and at 3 m3, 2 times 3 is 6, no? So in general derivative at x, I can say 2x, okay, of x, because it's a function of x of the point at x naught is 2x naught. So if x at 2, it will be 2 times 2, no? At 3, the derivative is 6. That is also the slope of tangent line. Okay, do you guys have any questions up to now? Okay, so there are two notations to give this derivative of tangent line or derivative at x naught. Okay, there. So here this one, this handout have that calculation of derivative. Okay, two notations, Lagrange and like Newton's. Okay, Leibniz and Lagrange. Okay, so one is saying derivative of, if y is equal to fx, derivative of y or the slope of the tangent line is given by this one dx. Here we are saying we are differentiating with respect to x. Okay, so differentiating with respect to x, uh, here, because my independent variable is x, so that is how much y change when I change x by 1 unit, no? That is the slope of the tangent line at that point. So for example, if my fx is x squared, then y fx x squared, I say dy by dx is 2x. Okay, we found previously. Okay, මේක notation දෙකක් තියෙනවා, derivative එක දෙන්න, එකකින් දෙන්න මේ dy by dx. Okay, then the other way to give derivative is saying just f dash of x. Okay, f dash of x 2x. Both of them are notation for give the derivative. Instead of saying find derivative, I can say find the dy by dx or find f dash x. Okay, either notation is fine. This one here we are saying for with what variable we are differentiating, but here I am not saying what variable I am differentiate with respect to it implicit. Okay, this independent variable. මේක මේ notation දෙකක් තියෙනවා derivative එක දෙන්න. එකක් dy by dx. හරි? අනිත් එක f dash x. ඒ දෙකෙන්ම දෙන්න පුළුවන් derivative එකේ notation එක. So now if I try to always use the definition of the derivative, it's little bit hard. Okay, I just wanted you guys to see it. If I always try to use this, it's hard. Okay, so people have constructed a set of rules. Okay, here these are the derivatives of basic function. You can get them using the definition. Okay, so here to here, these are the derivatives of simple functions. Okay, and then we have these rules. Okay, both of them, all of them are derived using the definition I showed you. Okay, මෙතන මේ d by dx notation එක පාවිච්චි කරලා තියෙන්නේ. මෙතන කියන්නේ සමහර basic function වල derivatives. මේ derivative එකක constant එකක derivative එක බිඳුවයි. Okay, because it's the rate of change. No, if I have a constant function, that means something like y equals 5 or y equals 6, a constant function. Then if I draw the graph, it's like this, no? Any point rate of change is 0 because y don't change with x, y remains constant. මේ constant function එකක් ගත්තොත් derivative එක බිඳුවයි නේ. මොකද y වෙනස් වෙන්නේ නැහැ. මේ x වෙනස් වෙද්දී ඒ constant ම flat තියෙනවා. එතකොට derivative එක constant එකක බිඳුවයි. Okay? For xn is given by this formula. We show that x, we will go for here. Okay, and sin x cos x negative sign, ln x 1 over x, exponential itself. Okay, derivative of exponential function don't change. එතකොට මේ constant එකේ බිඳුවයි මම මේ පෙන්වුවා වගේ xn වල derivative එක මේ form එකෙන් දෙනවා. sin x වල derivative එක cos x වලින් දෙනවා. cos x වල derivative එක negative sin x වලින් දෙනවා. ln x වල derivative එක 1 over x, ex වල derivative එක ex මයි. Okay, so then we have derivatives of these functions. Okay, these rules also obtained by using that definition. Okay, so all these derivatives are obtained using the definition, and all of these are rules are also obtained using the definition. මම අර definition එක පෙන්නුවේ ඒක පාවිච්චි කරලා මේ ඔක්කොම rules ගන්න පුළුවන්. හරි? ඒව ගන්න හැටි දැනගන්න ඕනේ. අර මම එකක් දුන්නේ ඒක දැනගෙන හිටියම ඇති. ඒක උදාහරණයක් හැටියට මේක තේරුම් ගන්න මේ rules ඔක්කොම මේ definition එකෙන් ගන්න පුළුවන්. Okay, so you don't have to know how I obtain these rules. Okay, these rules you can obtain using the definition like I showed here, taking the limit. Okay, using this definition you can obtain all the formulas. What you have to learn is how to apply those formulas mainly. Okay, you may need to know only this example, but other ones you just need to know how to apply the rules. Okay, මේ example එක දැනගත්තම ඇති තේරුණාම අනිත් ඒවා ඔයගොල්ලෝ මේ rules දාන්න තමයි ඉගෙන ගන්න ඕන differentiate කරන්න. Okay, So we will go over these rules and we'll see how to apply these rules. Okay. So first one is derivative of a constant function. I told you. So if you get a constant function, let's say y equals 5 or some constant, then dy by dx, we can say 0. Okay. Or f dash, if this is also labeled by fx, f dash x also 0. Okay. Any constant function. Then this power rule you have to learn. Okay. So let's say I want to find when x is equal to y and fx equals x to the cube. Okay. Find dy by dx. Okay. So if I want to find the derivative of this guy, what is do? You compare this. It look like this guy, no, xn. So here I identify the n. N is 3. Ne? Okay. So what I do, I bring down the 3. X, I go n minus 1. X 3 minus 1. Okay. So that gives me 3x squared. 3 minus 1, 2. So it gives me 3x squared derivative here. Three x squared. Okay. You bring down the 3 in front, comparing with this formula. Okay. If I do derivative of, if I want to do, let's say another one. Okay. Any question up to now? Okay. So I applied this formula. I bring down n in front and subtract 3 minus 1. No. Also, you can ask it in y format, or a dash format also. Okay. If I ask you to find the derivative of x squared using this formulas, again it with goes with this one, no? So I can say f dash of x. I bring the 2 down. 2 minus 1 is 1. I don't have to write 1. See the derivative of xn. X of the 2 is 2x. No, so this formula is you get by the definition. So you get the same here 2x. Okay. And it's interesting. derivative of a straight line. Okay, this is a straight line, no? Mx plus c. Okay, that one I'll come later when we do one rule. Okay. First we will finish this. Okay. So let's say I have y equals 1 over x to the 4. Now, how can I differentiate this one? I need to find the formula from this side, no? මට මේ එකයට x4 derivative එක හොයන්න ඕන නම් මේ පැත්තෙන් formula එකක් හොයන්න ඕන. Okay, so I am looking for dy by dx. Okay, I want to find the derivative here. So this is what I am looking for, derivative here. So what I have to do first, I have to rearrange this to look like this one. And write it by taking this x to the numerator, -4. Okay. So then to find dy by dx, now I can do, no? I bring down the -4 in front. I write x to the -4 minus 1, no? N minus 1. Here, because both of them negative, I have to add, no? So I get x to the -5. Okay. And let's say I have to find, let's say I give like this. Okay. It's always the same formula. Cube. Okay. So then if I'm looking for f dash, it's the same thing, okay, as dy by dx. So again, here I have to rearrange this to look like this guy. Okay, if you recall this one, we know it's x1 over 3, no? Because this cube root, when we have this, I write this as a 1 over power. Okay, I can write like this. So x to the derivative of x to the 1 over 3. I bring down the 1 over 3. Here I have to have what? 1 minus 1 over 3 minus 1, no? N minus 1. Okay. So here 1 over 3, if you take the common denominator, you get 3 over 3. So this is 3 over -2. Okay. So -2 over 3. If I want, I can make it positive by taking back to the denominator and write x 2 over 3. Okay. Any questions? This formula don't change. It's the same if I have different variable. Okay. So it will take the same form, then I can use the formula. For example, if I have y equals t to then derivative of dy by dt. Now my variable is t, no? Or if this is also ft, my variable is t. Or f dash t is equals to n tn minus 1. Okay. So that means if I have t to the 5, I can take dy by dt is 5t4. Okay, here I'm differentiating with respect to t now. Or if I have fx or even I can say y dash. Okay, you can say y dash. I bring down the 4, s minus 1. Okay, that means here I'm differentiating with respect to dx, s dy by dx. Okay, this form sometimes don't say what we are differentiating with respect to. You have to get it from the content. මෙතන මේ එකේදී අපි කියනවා dy by dx කියලානේ. ඒ මේකේ ෆෝම් එක නම් variable එක වෙනස් වුණාට ඒ ෆෝමියුලා එක හැමම apply කරන්න පුළුවන්. එතකොට t to the n නම් derivative එක මේක. එතකොට t to the 5, I bring down the 5 and then t to the n minus 1, 4. Okay. Do you have any question up to now? Yeah, the rest this and this. Okay. Now what we have to do is when we get a complicated function, we have to use these rules. Okay. Before going that, derivative of sine x is cos x. Okay. And derivative of cos x is sine x. So, okay. So if I ask you to differentiate cos x, I can directly say sine x. Then derivative of ln x is 1 over x. Derivative of ex is ex. So these basic functions are there. Then you will be given this rules. Okay, I'll give these rules in the exam, but try to memorize them. It will help. Okay, මේ rules example එකේදී දෙනවා. ඒවා memorize කරගන්න බලන්න. ඒ වුණාට memorize කරගත්තොත් ලේසියි. Okay. Let's go this one. Okay. Now the thing is, if you get a compound functions that made out of these basic functions, you have to use these rules. Okay, so for example, let's say I have to differentiate y equals 5 times sine x. Okay, find dy by dx. Here now I am looking for the derivative of this guy. Okay, I'm looking for the derivative of this guy, make a derivative එක හොයන්නේ. He is not listed here, see? Okay, it's not listed, sorry, it's not listed in this left hand list, it's not listed. Okay, so I cannot find the derivative of this guy directly because I don't, it's not a basic function, it's not, he's not listed here. Okay, then we have to apply a rule from this side to break it down to a derivative of one of these basic functions. So if I look at what rule matches with this one, easily I can see we have this constant multiple rule where a function is multiplied by a constant. So in the constant multiple rule, this side asks you to find the derivative of this constant times this function. Instead of that, that rule allow you to pull out the constant outside of the derivative and simply differentiate the function. මේ constant මේකෙදි මට මෙන්න මේ 5 sin x කියන එක මෙතන ලිස්ට් කරලා නැහැ. හරි, එතකොට එයාව කෙලින්ම ඩිෆරෙන්ෂিয়েට් කරන්න බෑ. එතකොට මේ පැත්තෙන් රූල් එකක් දාන්න ඕන. මම ඒක මේ පැත්තේ ඩෙරිවේටිව් එකකට බ්‍රේක් ඩවුන් කරගන්න. හරි, එතකොට මම මේ පැත්ත මැප් කරනවා මේ රූල්ස් එක්ක. කරලා බලනවා මෙන්න රූල් එකද මැච් වෙන්නේ කියලා. ඒක ගත්තොතින් මෙතන මේ constant times මේ function එක තිබ්බොතින් එතකොට අපිට differentiate කරන්න පුළුවන්. Okay, so what I can do, I can pull out the constant. Okay, now I pull out the constant using this first rule. Now that derivative is listed in this side. Okay, but derivative of sin x is listed here cos x. So at this point I differentiate. When I differentiate, the derivative sign go away. No, first I just rearranged it using this rule. I didn't differentiate. Okay, so when I differentiate this one using this rule, I get cos x. So the derivative of 5 sin x is 5 cos x. This is the final answer. Okay, if I look at another one, let's say I'm doing this. Say, let's say 10 ex or 100 ex. Here I'm trying to, if I'm trying to differentiate this, again, this function is not listed here, no? But I can use this rule and pull out the constant. 100 times derivative of ex, no? At this step, I am just pulling out the constant. I haven't differentiated. So this is here. Okay, මේ step එකේදී differentiate කරලා නැහැ, මම rearrange කරා විතරයි. මේ d by dx තියනවා. Okay, then I can apply this formula, no? Because derivative of ex is what? Ex. Okay, so I have 100 here and ex. Okay, even I can do it without a t, let's say 5 to the t3. Okay, here again I can, my variable is t now. Again, this 5 constant I can pull out. I get d by d to the t of t cube. Okay, now what I can use, t cube, I can apply this formula, no? Because it's the same form. So 5 will sit there. I'll bring down the t. 3 t squared. Okay, this is the derivative. 5 times 3 is 50 t squared. Okay, so change in the variable want effect, I can apply same thing. Okay, so also you can use f dash. Okay, for example, I get this 5 ln x. It's the same thing. Okay, find y dash. So this is same as saying find dy by dx. Okay, so if I'm looking for y dash, I can look say like this. I'm looking for the derivative of this all thing. How I express this in the dash notation? So I have to pull, this is the derivative thing. I can pull out the 5 outside of the derivative and write this, no, ln x. මේ dash notation එකෙන් දුන්නා ලියනවා නම් මෙහෙමයි මේ rule එකනේ. 5 එක outside derivative, this is inside. Now I know the derivative of ln x is 1 over x. So I get y over okay. So that is when compound function is made by constant multiplying the f by a constant. Okay. So let's say you ask to find this derivative of sin x plus cos x. Okay. Find dy by dx. Okay. So if I am given this one, this time I have to use this. I'll use the dash notation. Dash notation. Sin x plus cos x dash. Okay. So this is a this one again not listed here. No, if it's not listed here, I have to go this side and see what rule I can apply. Here there is some rule. Okay, it says what? Derivative of a sum is equal to the derivative of individual sums. මෙතන මේකෙදි බැලුවොත් මේක කරා මේ පැත්තේ නෑ. එතකොට මේක මැප් වෙන්නේ second rule එකකනේ. එතකොට මේක කියන්නේ derivative එකතුවක derivative එක වෙන වෙනම derivatives වල එකතුවට සමානයි කියලා. Okay. So this is allowing me to change the order here. No, this side I first add and then differentiate. This side I first differentiate, this then add. This rule is there to tell me they are the same. Okay. මෙතන කියන්නේ මුලින් එකතු කරලා පස්සේ differentiate කරන්න. මේ පැත්ත rule එකේ කියන්නේ මේ පැත්ත කියන්නේ මුලින් එකතු කරලා පස්සේ differentiate කරන්න. මේ පැත්ත කියන්නේ මුලින් differentiate කරලා ඊළඟට එකතු කරන්න නේ. It allows me to change the order. First add and then differentiate. Here first differentiate and then add. Okay, it allows me to change the order of this operation, sum rule. So here, because this one map with this guy, I can use the sum rule. No, so the derivative of sum is cos x, and the derivative of cos x is minus sin x. No, so this will become a minus sin x, because at this step I have these two rules. So here I can differentiate. Okay. Any questions? Now I'll let you try one. Okay. It's easy, I think. Okay. Okay, you can send me the answer in the chat. I'll give maybe 5 minutes. Okay, fine. Okay, can you send the answer for this one? මේකට උත්තරේ එවන්න බලන්න මම විනාඩි 5ක් දෙන්නම්. මේක ලේසි කියලා හිතනවා මම. Okay, good. We got one. Yeah, I'll wait few minutes too. Good, I think. 2 people answered. Thank you for it. I think they are correct. Good. Okay. Good. Okay. 3 people, they are correct. I will do more. Okay, good. Okay. 4 people, I think. They are correct. I'll wait 2 more minutes to see. So I'll go with this one. Okay. So I can apply the sum rule. Okay. So dy by dx. This one I differentiate this. Ex plus ln x. Okay. I can put the bracket to say both of them. Okay, or I can write it without it. So now sum rule says what? D by dx of this guy plus d by dx of ln x. Okay, you can skip this step. I am writing is to explain. Okay, so derivative of each individual function. No, so here I get dx. Okay, good. Another one friend. Okay, so answers are correct, all the people. So derivative of ex itself, no, it's a very nice function. When we think in terms of derivative, it's very simple. It's the same thing. Okay, derivative of ex is ex from this formula. Then derivative of ln x is 1 over x. Okay, okay. So actually මේක එතකොට ex වල එක exමයි. Okay, ඔයගොල්ලෝට ඕන නම් මේ step එක skip කරලා හිතෙන් කරන්න පුළුවන් නම් කෙලින්ම මෙතෙන්ට එන්න පුළුවන්. Okay, so if you can do it in mind, you can skip this and directly come here and do the derivatives of individual functions. Okay, but here I'm showing with notation to explain. It's better to have this some ways, but if you want, you can skip. Okay, now we'll go how to do derivative of sum of. I'll go to here, d by dt of, let's say I have three functions. Okay, now I want to do the derivatives of these three. So here sum rule is for two functions. Here I have three functions. Okay, but what we do, we can still use the sum rule. What I do, I think this function, I can either say these two functions, I can group together and think it as a one, or I could have grouped these two. It doesn't matter. Okay, මෙතන දැන් sum එක දාන්න ගියාම මෙතන function තුනක් තියෙනවා. මෙතන function දෙකයි. Okay, here මට එතකොට මේ දෙක එකක් හැටියට ගන්න පුළුවන්, නැත්නම් පිටිපස්ස දෙක එකක් හැටියට ගන්න පුළුවන්. මොක එහෙම කරත් වෙනසක් නැහැ. Okay, so then this function I think as g, and these two functions, first two function I will think as f. Okay, these two are my first function f, and this is my second function. I can do that because of the associative law. No, if we are adding numbers, I can add them in any order. So here of the first function, this is the first application of sum rule. Okay, plus Okay, so that is the first application of the sum rule. Very good. Okay, then again I can apply sum rule. So this function is not listed in this list, no? That's why I am applying the sum rule, first one. Now this is still not listed here, okay? So I go sin t plus, so I apply the sum rule for the second time, okay? Some of you have seen this, okay? සමහර අය මේක කළා ඇති සයත් මේක පළවෙනි පාර්ට් දකින ඇතින් හින්දා මම ස්ටෙප් පොඩ්ඩකින් විස්තර කරනවා. Now this one I can differentiate, no? Because it's listed here, this tn guy. So I bring down the 3 and t squared, okay? Now derivative of sine is cos plus et plus 3t squared, okay? Here again you can just jump and differentiate individual functions, okay? Individual function differentiate කරන්න පුළුවන්. මේක එතකොට එකපාරටම මෙතෙන්ට පයින්න පුළුවන්. හරි, මම එතකොට sum එක 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 derivative වල sum වල එකතුවට සමානයි මොන ගානක් තිබ්බත්. Okay, how many, it doesn't matter how many functions you have, even this work for a different. Okay, different rule also you can change the order here. See, so for example, if I had ln t, I can say d by dt of, here different, I'll skip the step this time. I can say this guy derivative of sine is what, cos t, minus derivative of ln t is 1 over t, no? Okay, now we can apply these two rules together also. Okay, so if I say find I'll use the dash notation. Any number of these things. Okay, so this one, if I ask to find the derivative first, I'll use the dash notation for this side. Okay, I can break it down into derivatives of individual functions using the sum and different rule, no? So here first I do this, and derivative of this guy, I use the dash notation because it's easy. Okay, so this is equal to derivative of this, individual derivative of this, minus then from the different rule dx dash. Okay, so here first I applied the sum rule, no, breaking it by each individual sum and the different rules. Okay, මෙතන මුලින්ම මම sum and different rule එක දැම්මා. ඊට පස්සේ මේ individual function differentiate කරන්න ගියාම තාම මේක මෙතන list කරලා නැහැනේ. Okay, so here these are constants, no? I can pull out the constant next. So first I applied the sum rule, now I am applying the constant rule. Okay, first I apply the sum and different rules, now I am applying the constant rule. Okay, this one is listed here, so I can differentiate him, no? Now these are different listed here. The derivative of sine is cos. So I write cos x here. And this guy is minus sine, no? Derivative of cos is minus sine. So this will become a minus 5. And then 3. Derivative of ex is also listed here. Ex, so 1 over x. So first we keep applying rules from this side until I break it down to one of these guys, okay? So some rule I can apply at once and say here I am applying some rule 3 times, okay? Because 4 functions, but I can directly apply it and say this derivative of individual guys that separated from the sum and different. Okay, if you want me to further explain this, let me know. Okay, any questions, or do you want me to explain this? Okay, good. Okay, now we'll go to product rule, but before that, do you guys have any questions from worksheet or from homework? Worksheet වලින් හරි homework එකෙන් හරි මොනවා හරි ප්‍රශ්නයක් තියෙනවද? එහෙම නැත්නම් මම okay, I'll do the product rule then. So observe that this sum rule allow us to change the order of the operations. No, first do the sum here. First do the sum and then add the then differentiate. But this side, so this side is saying first do the sum and then differentiate. Okay, but this side said first do the differentiation and then after that do the sum. Okay, here first add the two functions, then do the differentiation on the resulting function. Here individually differentiate each function first and then add. So here I'm adding after differentiating. Here I'm adding before differentiation. So this rule allows to change the order. Okay, but if the product rule followed the same pattern, we should get here this. Okay, if I have this derivative of product, I should be able to do this. Okay, but unfortunately there is no rule to do this. Okay, so this is completely wrong. You cannot change the order of differentiation of a product simply because its rule is more complicated. Okay, remember that even we do in normal life, we cannot always change the order of things. Okay, for example, if you are driving a car, if you want to turn, first you have to put the turn signal and then make the change. You cannot first turn and then put the turn signal. It's wrong. මෙතන මේ අපේ sum function එක ගොඩක් හොඳයි අපිට මේ order එක change කරන්න උදව් කරනවා යා. මෙතන මේ පැත්තේ තියෙන මුලින් එකතු කරලා පස්සේ differentiate කරන්න. මේ පැත්තේ තියෙන්නේ මොකද්ද? මුලින් differentiate කරලා පස්සේ එකතු කරන්න. එතකොට product rule එකත් ඒ pattern එකම follow කරා නම් මෙහෙම එන්න ඕන නේ. මුලින් වැඩි කරලා පස්සේ differentiation සමානයි මුලින් differentiate කරලා පස්සේ වැඩි කරන්න. මේක වැරදි. අපිට සාමාන්‍ය ජීවිතේ වුණත් ඕන විදිහට මේ orders වෙනස් කරන්න බෑ operation වලනේ. උදාහරණයක් හැටියට අපි වාහනයක් එලවනකොට හරවනවා නම් මුලින් signal එක දාලා ඊට පස්සේ හරවන්න ඕන. මුලින් හරවලා පස්සේ signal දෙන්න දැම්මට වැඩක් නැහැ. හරි? එතකොට මේ product rule මේ sum rule එකේ අපිට order එක වෙනස් කරන්න පුළුවන් වුණාට product එකේ එහෙම order එක simply වෙනස් කරන්න බෑ. ඒක වැරදි. Okay? product එකේ order එක තියෙන්නේ මෙන්න මේක. මුලින් මෙතන මේකෙදි කරන්නේ මේ f and g තියෙනවා නම් මේකේ මුලින් මම f එක differentiate කරලා original function g එකෙන් second එකෙන් වැඩි කරනවා plus first එක differentiate කරලා second එක differentiate කරලා first function එකේ original එකෙන් වැඩි කරනවා. Okay, so the product rule here differentiate the first function times the original second function plus differentiation of second plus the original of the first. Okay. For example, let's say I have to differentiate this guy. Okay. Okay. So here I need to use the product rule. Okay, I'll use dy by dx notation. I have to differentiate this guy. Okay. So this one is not listed here, no? This one is not listed here. So I have to apply one rule from this side. Okay, so this one map with the product rule, no? Because it's a product of two functions. So to apply the rule, I have to identify f and g here, no? So my f is the first function and my g is the second function. Okay, so I say equal so according to this rule, I have g times sorry, g times df over dx plus f times dg over dx, no? Okay, so when I use here first g, no, I'm plugging in for formula, so g is sine x. I just write sine x. Okay, then I have to do derivative of f, that is x cube. Then f is here x cube, g is sine x. Okay, so I apply the product rule here. Okay, just plugging in. So here I have sine x. Now I have to differentiate this. So here I look whether it's listed here, then I can differentiate. Okay, otherwise again I have to apply a rule. But if I look here, it's here, it's listed here. So this n1, no, it's listed here with this n1. So I can write 3 n minus 1, no, n is 3. So 3 n minus 1 is 2. Okay, that is the first one. And x cube, this function is listed here, so that is the derivative of cos x. Okay, so it's better to write this 3x squared in front. So I will write 3x squared here. Okay. Any questions? Okay, I'll give you one to try. Okay, then we will do it in T, and the dash notation, and it's the same. Okay, even I change the letter. I will. Okay, so try to do this one. I'll give 5 minutes. You can send the answer. Okay, you can skip the middle step if you want. You can just send the answer. Okay. විනාඩි 5ක් දෙන්නම් මේකේ උත්තරය එවන්න කරලා. Okay, good. I got one. Very good. Okay. I got three. Good. Okay. I got 4. Yes. I'll wait 1 more minute to see it. Okay, good. Thank you for the answers. Okay, I got 4. They are correct. Okay. Okay, I'll use the dash notation for this problem. Okay, good. I got 5 or 6 answers. Good. Okay, good. All of them are correct. 6. Okay. One, there is a small mistake in the sign. One of them. Okay, one of them, there is a mistake in the. Okay, yeah, one of them, there is a mistake. Oh no, that is the previous problem, I guess. No, yeah, this one of. So here, this is a product, no? So I use the product tool. This time I use the dash notation. Okay, et. I'm looking for this derivative. Dash. Okay, I'll say this one f g. Okay, I'm looking for. Now the sum will give second function times first function times second, no? Here this thing, second function times the derivative of first plus first function times derivative of second. Okay. So I can go now. My first function is et. Sorry, second function is cos t, no? So g is cos t, I write here. G is cos t, I write it here, times the derivative of first function et, no? Plus f is et, first function, no? Times the derivative of the second function. Okay. Now I come back and see whether these individual functions, whether I apply this or this side. The derivative is et is here, so I can apply this side, no? I'll do cos t et, then derivative of et is et from this formula, no? Plus here this is et, derivative of cos becomes minus sine, no? So this minus sign, I can write it at here. At the same time, this common factor et I can pull out, no? So if I pull out the common factor et, this is simplifying, okay? you are done with differentiation with this part. You can stop there if you want. Okay, but it's better to simplify. So cos t, this will become a minus sin t. Okay, okay, මෙතන differentiate කරද්දී එතකොට මම rule එක දැම්මම මෙතන f differentiate කරන්න ඕන, ඊළඟට g differentiate කරන්න ඕන. මේක differentiate කරාම මෙතන e එන්නේ නේ, මෙතන differentiate කරාම sin එන්නේ. ඊට මෙතනදී differentiation එක ඉවරයි, මෙතනින් නවත්තන්න පුළුවන්. හැබැයි මේ et එක common හින්දා අපිට එළියට ගන්න පුළුවන් ඒක. okay, ඕනනම් මෙතනදී නවත්තන්න පුළුවන්. Any questions? Oh, okay. Okay, then I'll go ahead and do one with 3. Sin t, I will write without the brackets. Okay, so this is same thing. I find the derivative, no? Okay. So here I'm looking for the derivative of this guy. Okay. T, here there is product. Okay. Now again, this is not listed here, no? So I have to apply one of rules from this side. My right with 2 functions. Okay, so I cannot apply product rule for 3 functions at once. Okay, so what I'm going to do, I'm going to group 2 of the functions together. Okay, for at first run. So here I will say these two together g, and this is f. I could have done other way. I could have said these two f and this one g. Okay, it doesn't matter. මෙතන දැන් මම ආයෙ බැලුවොත් මෙයා මේ පැත්ත ලිස්ට් කරලා නැහැ. එතකොට මේ පැත්තෙන් රූල් එකක් දාන්න ඕන. මොන රූල් එකද කියලා බලද්දි මෙතන ප්‍රොඩක්ට් එකක් තියෙනවා නේ. ඒකින්ද ප්‍රොඩක්ට් රූල් එක දාන්න try කරන්න පුළුවන්. හැබැයි ප්‍රොඩක්ට් රූල් එක දාන්න try කරද්දි මට එක ෆන්ක්ෂන් තුනක ප්‍රොඩක්ට් එකක දාන්න බෑ. හරි එකපාර. එතකොට මම ඒක දෙකක එකකට කඩා ගන්න ඕන. එතකොට මම මේ ෆන්ක්ෂන් දෙක ගෲප් කරලා g කියලා මෙයා f කියන්නත් පුළුවන්. එතකොට ෆන්ක්ෂන් දෙකයි එහෙම නැත්නම් මේ දෙන්න එකට group කරලා එයා F කියලා මෙයා තනියෙන් G කියන්නත් පුළුවන්. ඒක ඕන විදිහකට යන්න පුළුවන්. Okay. So this time I choose to go this way. Okay. So if I apply the formula, here I have G F times F G, no? Okay. Here this is dash derivative of the first function, and here derivative of the second function there. Okay. So I will write G is sin t ln t. No, G is sin t ln t. So I'm plugging in for him. I get sin t times ln t times f dash. Okay, I will write it here. T q dash. So I plug in for f and g. G is this guy. Okay, plus f. F is t q times d dash. D is sin t ln t. No. Now I come for next line. Here, this is sitting here just sine of t and derivative of this I bring down to 3t squared plus t cube dash. No, sorry, I didn't write the dash here. Now derivative of this one. So this guy times derivative of first, this guy times derivative of this here. For this one, yeah, is a derivative, no? Its derivative is it's mapped with this guy, so I can directly differentiate him. Okay, but this guy again is not here, so I have to apply a rule from this side. Okay, මෙතන මෙතන එක්කෙනා මේ ලිස්ට් එකේ ඉන්නවනේ මේ form එක xn. I can directly differentiate him, but for this guy it's not listed here, so I have to apply a rule from here. Again, this is a product, no, of two functions, so I can apply the product rule saying this is f and this is g. Okay, so if I apply the product rule here, I get t cube, again here green f, green g times derivative of the f dash plus f original function times derivative of the second. Okay, so here this t cube have to multiply everything. Okay, so I have to have a bracket here. So f dash here I will write g, no, my g green one is here ln t, and the derivative of f dash is the derivative of sine t. I write a dash here. Okay. Plus other way around, no? You can skip some steps if you are familiar enough. Okay. Now f is sine t. Okay. Then derivative of g. G is ln t, no? dash. Okay, and here I close. Now I come here. Oh, sin t is fine, so I can keep the sin t. Then ln t, and 3t cube is better to write in front. Okay, this look nicer if I write. It doesn't matter, but you can write t cube. 3t squared. No, not t cube. Sorry. This should be 3t cube. This guy. No, it's better to write it in front. Okay. Now here I have t cube 1 over t derivative of sine t is cos t. Okay. Sine t. So derivative of sine t is directly listed here. Now cos t. Okay. And then sine t derivative of ln t is written here 1 over t. So here I apply the product rule 2 times. No. Here also you can skip some steps if you are familiar enough. Oh, this one I don't made a mistake. No, sorry. Take your time now. Let me. I differentiated del and y. So here, sorry, this ln t is here. No, so ln t and derivative of sine t is cos t. Sorry, okay. This one, derivative of this one is here. So I don't have to apply rule. Then sine t times derivative of t is 1 over t. Okay, you can simplify it a little bit more, but I leave it like this. Okay. මේක එතකොට දෙපාරක් දැම්ම හැමතිස්සම අපි කරන්නේ මේ පැත්තෙන් රූල් එකක් දාන්න බලනවා බැරි නම් මේ පැත්තෙන් එකක් දානවා ඊට පස්සේ එක එක ෆන්ක්ෂන් එකේ මේ පැත්තෙන් පුළුවන්ද කියලා බලනවා ඒ පැත්තෙන් බැරි නම් ආයි මේ පැත්තෙන් එකක් දානවා okay so this is here we'll do this Saturday also okay because ඕගොල්ලෝට බැරි නම් ඕගොල්ලෝගේ බෑච් එකට කෝල් එකක් දීලා වෙන දවසක් දාගන්න කියන්න අපි Saturday එකහමාර 3හමාර session එකක් කරමු 3 hours okay බැරි නම් බෑච් එකට කියන්න කෝල් එකක් දෙන්න කියලා මේ differentiate කරන හැටි තව කතා කරන්න මම එතකම ඔයගොල්ලෝට try කරන්න problems කීපයක් දෙන්න okay Saturday 1:30 to 3:30 can we do that 1:30 ඉඳලා 3:30 වෙනකම් මේ Saturday බැරි නම් කියන්න අපි එහෙම වුණොත් බෑච් එකට කතා කරලා මම වෙන වෙලාවක් දාගන්නම් okay this Saturday 1:30 to 3:30 එහෙනම් okay Okay, can we do it on Sunday morning then? ඉරිදා 8ට වගේ පුළුවන්ද? ඉරිදා 8:11 පුළුවන්ද? Okay, we'll do that then. Okay. ඉරිදා බැරි කට්ටියක් ඉන්නවද? එහෙම වුණොත් මට බැච් රෙප්ට ඔයගොල්ලෝගේ කෝල් එකක් දෙන්න කියන්න වෙලාවක් අපි දාගමු බලලා. නැත්තම් බ්‍රහස්පතින්දා උදේ වගේත් පුළුවන්. බ්‍රහස්පතින්දා උදේ හවස පුළුවන්. Okay, Sunday then good. Okay, so Sunday month 8 to 11. Okay, මේ differentiation ටික ඉවර. මේ ටික try කරලා තියන්න මම කතා කරන්න. Okay, here I should say y equals. Okay, okay. හතෙන් පස්සේ මට හතෙන් පස්සෙත් පුළුවන් හැමදාම වගේ. ඕකේ. ඕකේ. එහෙමනම් හතෙන් පස්සේ හොඳ නම් 7:30 to 10:30 Sunday. Okay. මේ මේ වෙලාව කමක් නැද්ද? හතෙන් පස්සේ පුළුවන් නම්. මේ දෙකෙන් එකක් එහෙනම් ඕගොල්ලෝ කියන්න මොකද්ද හොඳ කියලා. Sunday hari Saturday hari 7:30 to 10:30 hari Saturday 8 to 11. Here I have set. Okay. This one part A, let's say B and okay. එතකොට මට කෝල් එකක් දෙන්න අපිට 7න් පස්සේ ඔයගොල්ලෝ කියන්න දැන් පුළුවන් නම් කියන්න 7:30යි 10:30ද හොඳ 8:11ද හැමෝටම පුළුවන් වෙන්නේ. Okay, everyone, is it Sunday 8 to 11 or 7:30 to 10:30? Which time is better? Okay, 8 to 11. Okay, then we'll do 8 to 11. Okay. Okay, මේක වෙනස් කරන්න ඕන නම් කියන්න මට කියන්න. Okay. අපි මේ වෙලාවට දාලා තියෙනවා ඔයගොල්ලෝ වෙනස් කරන්න ඕන නම් back step එක කියලා මට කතා කරන්න. Okay, if you want to change it, so it's now Sunday 8 to 11. If you want to change it, let the batch rep know and they can call me to fix a time. Okay, so you can write this down and you can log out if you are done.
Thank you, sir.
Okay, welcome. Okay. Hey, ඔයගොල්ලන්ට මුකුත් නැත්තම් log out වෙන්න මොනවා හරි ප්‍රශ්න තියෙනවා නම් අහන්න පුළුවන්. නැත්තම් log out වෙන්න. Welcome. Okay. ඒ ප්‍රශ්න නෑ වගේ මම log out කරනවා. Okay, කාටවත් ප්‍රශ්න නෑ වගේ මම මේක log off කරනවා.